All right, and we're recording. So when we're doing things with Excel, the easiest thing that we can do is if we have a data table like this already, what we can do with the data is if we open up Excel, we're just going to choose a blank spreadsheet. So blank spreadsheet is going to look something like this, where it's just a series of rows and columns here. And those rows and columns can all be potentially filled with information. Now, if I was inputting my own data here, like say from a lab where I've done some data collection and now I want to do the data analysis, I would want to do things like put in column markers like trial number, concentration, time of reaction, those kinds of things. If you want to resize any of these columns, you'll notice that if you hover over the border between column A and column B, your cursor changes from a down arrow to a double-sided arrow like this. That would allow you can click and drag to change the width that way. Or probably the easiest way is if you double click, it'll automatically resize each of the columns to the correct width of the thing that you're trying to, whatever the biggest word is in that column. Now I actually want this trial a little bit bigger, so I'll go like that. But that's how you do it. And then you could put in your data and go from there. So that's what you can do if you have data that you need to input into Excel first. Now, in this case, we've already been given a data table in exercise 1. All that we need to do is just use it. And so the nice thing about everything that's in the Microsoft platform is that you can easily interchange them from one place to another. So I want to click on this and I'm going to copy the table. So I'm going to hit Control C, or if you're on a Mac, Command C. And then I'm just going to hit Command or Control V where I want to put that table, and it should drop it right in for me. And there it is. And so now I can resize it if I want. I'm going to resize it a little bit.
Yes.
Now, the other thing I want to do at this stage in the game is I want to tell Excel that these are actually numbers. Now, Excel does tend to assume things, but if we want to take into consideration things like significant figures, or we want to look at making sure that we are getting things calculated and that they're actually treating these as numbers instead of text. What we can do is if we click on data here, okay. Oh yeah, okay, here it is at home. I'm sorry, at home. If you click on the home button here, right now it has these cells listed as just general data. If I click on that down button here, I can turn these all into numbers. And by default, it's going to set them all as having identical precision, which in this case means 2 decimal places. For temperatures, we usually only get 1 decimal place of precision. So I'm going to click on this button here underneath the number. It's got an arrow that's pointing in to the right, saying that to decrease the decimal. I'm going to do that. so that it decreases the decimal down to 1 decimal place for me. So I now have a data table in place. How do I use this data table to make a graph? Because in number 1 here, it says I need to insert a graph of these data by copying and pasting it or taking a screenshot. Make sure that it has a title, axis titles, and data points that are connected with smooth connectors. So how do I make that graph so that I can do that task? Well, there's a number of ways that you can make a chart in Excel. You can go to Insert. And then over here, you see a series of recommended charts. We're asked for a line graph here. So we're going to choose the one that looks like a bunch of lines that are connected to each other. And I'm going to choose the line graph with markers, just a simple 2-dimensional graph. And at this point, a big blank box is going to show up. Why a big blank box? Because we haven't told it where the data are. All that we told is that we want the data to be a line. To actually do it, we need to go to Select Data. And we are going to add a series. And so the name of the series is Solubility of barium chloride, BaCl2. For the Y values, I'm going to click on this icon here. This icon here is the go-to chart icon. It's going to allow us to go to the data table, the spreadsheet, and choose our data. So for the Y values, I want the solubility data. So I'm going to click and drag over all of those solubility data points that I want. And then I'm going to click on this bar to go back to the dialog box. And there it is. Now for the horizontal axis, I'm going to go here. And I'm going to do the same thing. I'm going to pick the temperatures. And then hit OK. And now you can see that it has plotted this as a line chart. But there's one problem with this line chart in particular. If you look closely, and I'll expand it for you that you can see. This line chart shows just what the data are, and it gives them labels, kind of like a bar graph. But the problem is, if you look closely at the axis, every single one of these data points is the same distance apart, even though the numbers on the graph are not the same numerical distance apart. To go from here go between our first data point and our second data point, you'll notice that that is a gap of 10 degrees. And between the next two, it's also 10 degrees. Well, between the next two is actually 20 degrees. So while this is a good looking graph, the problem with it is that it's not representative of the data itself. It's showing all the data as being kind of equivalent in value against each other. So from that standpoint, a line graph is actually not the graph that we want at all. So I'm going to click on delete here. And we're going to try this again. Now this time I'm going to show you the other way that makes a graph. So I showed you the way where you can go to insert graph and choose whatever graph that you want. This time, what we're going to do is we're going to click and drag over all of our data. And now we're going to go to insert graph. And this time, instead of choosing the line graph, we're going to choose this one that looks like a bunch of dots in the middle bottom. This is called a scatter plot. Scatter plots are going to make up the majority of the graphs that we make in this class, because scatter plots give us that spacing relative to the numbers themselves. So if I click on scatter plot, I'm going to choose, in this particular case, the scatter plot that connects everything with smooth markers, because that's what was asked for. And because I've already pre-selected my data, you can see that Excel has kind of gone out of its way to guess that the temperature, because it's in the leftmost column, is the horizontal axis, and that the solubility, because it's in the righter column, is the vertical axis. And so now I have a scatter plot, and notice that the difference between the data points those two are 10 apart, but they're also 10, and those are 10 apart as well, but they're equal distances on the scale. This one is 20 apart, but it's also 2 blocks away. This one's 20 apart, but it's 2 blocks away. This one's 20 apart, but it's 2 blocks away. So a scatter plot takes advantage of showing us the differences between our gaps in our data. Now, this graph is far from perfect. There are some things that we need to add to it to make it better. So we need to add a chart title. Now, to change the chart title here, I can click on the chart title and type in what I want it to be. Solubility of barium chloride at various temperatures. But even that is not good enough either. I really need axis labels on the 2 axes. Now, in the Microsoft version of this, you should have a plus button that is kind of appearing as you float over the chart here. That's missing from this one. What you have to do on the Mac is you have to add chart elements up here at the top where it says add chart element. And so I can add axis titles from here. I can also add other things, like if I wanted to add a legend, I could add it and then tell it where I wanted it to go. If I wanted to add a trend line, I could tell it what kind of trend line I wanted. Since this one doesn't require trend line, we're going to just keep that at none. I can add more grid lines. I can take away grid lines. I can add data labels that tell us what each of the values are. And all those are really, really cool. There is a shortcut to it. If you go to these quick layouts, you'll see that there are some quick layouts like this one right here, which gives you axis labels plus a legend. And if you don't want the legend, all you have to do is click on it and hit delete and it goes away. And if you need to do a scatter plot with a trend line, this one here with the FX on it will automatically plot a linear trend line for you. But for us, we're just going to kind of keep this simple, at least for the beginning here. Our vertical axis is the solubility of barium chloride, and this is grams per 100 grams of water. And the x-axis here is the temperature. In degrees Celsius. So when we put axis titles on, we want to make sure that we tell what it is. And if it is a measured value, we want to make sure that we give the unit for that measured value. That's why I've got the grams per 100 here in the vertical, the degrees Celsius here. Now, if you don't like the sizes of any of these, if you want to increase the font size, for example, you can click on any axis. And if you go back to home, you can change the size just by simply going to the font menu here and changing the size accordingly. So I want to make the axes a little bit bigger. I want to make the labels a little bit bigger. I want to make the chart title a little bit bigger, maybe make it bold. And I can do all of those things inside of this menu right here. So I go ahead and I compare. Did I do all of the things that it asked for? Do I have a title on the graph? Yes. Do I have axes, titles, and labels? Yes. Do I have the data points connected together, smooth connectors? Yes. So what I can do is I can just pick this graph up. So highlight it, and you can either use the copy paste tools here at the top, or again, Control C, and then go over to Word. And Control V to insert the graph. And it'll eventually, again, things are moving a little bit slow for me today here, but eventually it will bring that graph over. Now in this particular graph, to answer B and C, since we do not have a trend line, all we're asking you to do is to estimate the solubilities at the temperature for B, or for C to do the estimation of the temperature. That you can do rather simply. So to estimate the solubility at 75 Celsius, I can go to 75 Celsius, which is about right here. Draw a line up to the graph. Draw a line over from the graph to the axis and estimate, okay, this is about 65 grams per 100 at 75 degrees Celsius. For part C, 45 grams per 100 would come out to be, it looks like about 45 degrees Celsius as well. And so with this one, all that you're being asked to do is estimate. So that's number one. Now, one more thing I'll show you before we get into breaking out and letting you try some of this on your own is what if you do have to add a trend line? So if I go back to this particular drawing, go back to this one overall. If I had to add a trend line, again, the way to do a trend line is one of two things. You either go to your chart design and add a chart element, add a linear trend line, just like that. When you do that, there are a couple things that you want to do. So when you click on that trend line, it should open a format trend line option on the right-hand panel. What you're interested in is the little thing that looks like a bar graph here. This allows you to change the trend line if you so choose. Of course, if you choose the wrong trend line, it gets mad at you because it says that you can't do it. But it allows you to do things like forecasting. So right now it is plotted the trend line just relative to your data. If you wanted to forecast it back or forward, you could. And what it would do is, so let's say that you wanted to look at the last data point was 80. The next data point, I wanted to look at 85, or I wanted to look at 100. So I forecast 20 ahead, and it kind of looks at it that way. Or if I wanted to look backwards, I'd be able to do that as well. If I wanted to set the intercept as 0, it would allow me to do that as well. But the really important thing, the thing that we're after the most, are these last two items here at the bottom. We want to display the equation on the chart. And I'm going to blow that up because that is tiny, tiny, tiny. So that's the equation in slope-intercept form for the trend line that we just plotted. And the other thing that we want to do is we want to select this r² value. Now, r² is a detection and measurement of what is called linear fit. That is, how well does this line represent these data that it is graphing? And the general rule of thumb for r² is that the closer to 1, the better the linear fit is going to be. Now, yes, if I go away from linear, if I go into a power function or a logarithmic function, you'll be able to see that the r² value is going to change accordingly. But for the most part, we only deal with linear fits, mainly because they're the easiest to work out. But the closer we are to 1, the better the linear fit is going to be. A fit of 0.95 or better is considered okay. A fit of 0.975 or better is considered good. A fit of 0.99 or better is considered excellent. And the better your equipment is, the better the expectations are that you come closer to that 0.99 or even higher mark. And so, analytical chemists, for example, usually look at their values in terms of how many nines they are able to get. Is it going to be 0.99? Is it going to be 0.999? Those kinds of things. So we can see that this graph is actually a poor linear fit, and it makes sense. You look at the dotted line against the smooth line, and they look like they have nothing to do with each other. They're kind of all over the place. So if you have to do a graph of this kind, where you have to submit the trend line, the trend line, again, gives us in slope-intercept form the equation of the line. So you go to those kinds of questions that we just did. If you were given a value that would fit in as a y, you can substitute that in for the y, solve for x, and get the value that you're looking for. And same thing, if you're given a value of x, you can sub it in for the x, solve for y, and get a much better clue about what it is that is going on. So that's it for this particular demonstration. I'm going to turn off the recording for now. And